from hundreds of weather observation sources, including weather balloons, aircraft and airport weather stations, ships, and satellites are fed into a supercomputer and turned into a weather forecast. The atmosphere behaves according to the laws of physics. This behavior can be described by very complex mathematical equations. Thousands of weather readings are fed into the computer and processed using these equations. The computers take that data and turn it into simulations or models. These models illustrate possible outcomes for existing weather patterns. On this system, we can show relative humidity, temperature, or precipitation.
What the models do is develop a series of forecast maps of what the atmosphere is supposed to look like from about now, from initial conditions out to about 12 days. Okay, so let's go to the computer, and here we can see the jet stream outlined in the blue and red colors, which is the main core of the high-speed winds.
With each additional day we look into the future, the forecast of the position of the jet stream becomes less accurate. The jet stream is the engine that drives the weather over North America. Jet streams are relatively narrow bands of high-speed winds in the upper atmosphere. Their general direction is west to east, but they can swoop northward and southward. In general, the twists and turns of jet streams follow the boundaries between warm and cold air. Watching the jet stream is an important part of weather forecasting.
Another tool which has helped improve the local forecast is Doppler radar.
Doppler radar, like regular radar, can detect clouds and even water droplets within clouds. Where it differs, though, is that it can also detect the motion of winds within a cloud. Doppler sends a radar beam of a known frequency into a cloud. If the beam returning has a lower frequency, it means the wind is moving away from the radar tower. A higher frequency means the wind is moving toward the radar tower.
The really neat thing about Doppler radar is that it can show when tornadoes are forming. An example here in the Maryland suburbs shows a tornado in Prince George's County. These yellows and oranges show air moving away from the radar, while these greens and blue colors show air moving towards the radar. The colors in the middle are where the tornado is located. So in effect, what we have are high-speed winds moving in opposite directions very close together. The air in between gets spun very fast, and that's a tornado.
Predicting severe weather is the most challenging part of a meteorologist's job. All over the world, some 45,000 thunderstorms erupt each day. The basic ingredients for their explosive brew begins with warm, humid air, called updrafts, rising above the earth and condensing into clouds. Ice crystals, or water drops, grow heavy enough to fall to earth, and the rains begin. The precipitation creates downdrafts. Updrafts continue to feed the storm, but as downdrafts grow, they eventually choke off the updrafts. With its supply of humid air cut, the storm tapers off and dies.
I heated up some water to represent basically a lake, a river, a stream, or something like that. It's a little hotter than normal, so don't worry about it. I'm gonna put it in. Once I put it in, I want you to put the cover over top of it. And then write down your observations and watch what happens.
Heating and cooling are basic to the mechanics of weather. These students at Ann Beers, a public school in Washington, D.C., are observing the mechanics of weather by making some weather of their
I
own.
want you to put the saran wrap over the top so you can trap the moisture inside of it. Make sure it's on nice and tight. So have the rest of you guys write down your observations.
By constructing these closed environments, they will actually see one weather force at work.
I want you to watch and see which side of the mountain the cloud forms on. Is it the side with the water or without the water?
As the water-laden air cools, clouds form. Observing and identifying clouds is an important part of learning to tell the weather.
This is a good cloud.
Clouds come in all different shapes and sizes, but there are three basic types of clouds. Cirrus are the thin, wispy clouds we see high up in the sky. Because they're so high, where the air is cold, they're formed of ice crystals.
This is a good cloud.
The flat clouds that appear in sheets or layers across the sky are called stratus clouds. They are often associated with a warm front. Then there are cumulus clouds. Cumulus clouds are the puffy balls we see on warm, sunny days. They're formed by rising air. They may grow into thunderstorm clouds.
Lightning occurs because there's a separation of huge pools of electricity. Near the top of the cloud, where temperatures are below freezing, ice crystals tend to hold onto positive charges. The raindrops consist of mostly negative charges, and there's a positive charge beneath the cloud. Lightning flashes in a thunderstorm between the pools of various charges, and it also flashes from the base of the cloud to the ground. By far, the most common lightning is between areas of differing charges within clouds. This is called intercloud lightning. You can always tell how far away the thunderstorm is by slowly counting to 5 after you see the lightning. And then each time you reach 5 before you hear the thunder, it's a mile away. So if you count to 5, it's a mile away. If you count to 10, it's 2 miles away. If you count to 15, it's 3 miles away.
The Tyrannosaurus rex of thunderstorms is called a supercell. These colossal storms can keep up their assault for hours, complete with driving rains, damaging hail, deadly lightning, and a full arsenal of highly destructive winds, including tornadoes.
They just issued a tornado warning for right where we are.
This is Howard Bluestein, professor of meteorology at the University of Oklahoma.
Yeah, right over here there is. Right over here, the circulation, right over here.
He and his crew are tornado chasers.
Take out the radar right now. Let's give it a try. Okay.
It's a risky business. If they actually find a tornado forming, they have to be ready to run.
Okay, we better get going quickly. That thing is starting to form a nice funnel. Actually, hold it. Can you turn it on? Oops. Up. I think we'd be good here. Let's try it.
With their portable Doppler radar, they've measured winds that have topped 350 kilometers per hour.
We're actually a little bit close.
Tornadoes are weather on the rampage. We say a tornado is touching down. What is really happening is a tornado is sucking up debris from near the ground into its menacing funnel. A great rush of twisting air tears loose everything in its path and turns everyday objects into missiles.
Tornado on the ground. It looks like it's tearing through the town of Laverne.
When one of these deadly storms touches down, chaos and despair usually lie in their wake. If tornadoes are small, short bursts of weather's fury, then hurricanes are large, long-lasting rages. These giants can stir up more than 1 million cubic meters of the Earth's atmosphere every second and whip up swells higher than 5.5 meters on the open ocean. Yet, they have humble beginnings. In the summer and fall, the sun heats vast stretches of tropical ocean to over 28 degrees Celsius. Warm, moist air rises over these hot spots, forming bands of thunderstorms. Upper-level winds push storms eastward as surface winds spiral into the low pressure beneath the clouds. Occasionally, one such spinning wheel of thunderstorms gathers strength, feeding on moisture and heat. When winds reach 119 kilometers per hour, a hurricane is born. The storm structure is highly organized. Rain bands up to 500 kilometers long converge in the most violent sector, the eye wall. Here, winds up to 300 kilometers an hour spiral upward. Within the eye, downdrafts of air create an eerie calm. A tornado that lasts an hour is extremely long. Hurricanes may continue to gain strength for more than a week, and though their winds don't always spin as fast, hurricanes cut a much wider swath of destruction than most tornadoes.
Clearly there's been a lot of damage, but this can only...
Hurricanes were first named officially during World War II. That was to help both ship captains and pilots avoid confusion when they encountered two or more storms along their route.
Each year, the naming starts with the letter A and continues through the alphabet. When severe weather threatens, meteorologists need all the information they can gather to assess the situation.
And we get data continuously, not only throughout from the United States, but throughout the world to get a real picture of the weather.
Across the lakes. As we move out to day 4, the European model is showing a somewhat different scenario with the mean trough farther to the west. UK Met is also showing the mean trough farther to the west.
Then we also have our local network that we call our Channel 4 Weather Interactive Demonstration SchoolNet.
Each school is equipped with a weather station, which includes a thermometer, barometer, anemometer, and wind direction indicator. The data from these instruments are fed directly into a classroom.
68.9.
And what about the dew point?
Dew point's around 38.
Okay, Robbie, what do you have for the temperature?
Around 76, Oliver.
What I like about this stuff is that we can tell if the wind is coming out the south or southeast and the barometer is dropping, we will have a little bit of precipitation.
The data also go directly to the Channel 4 Weather Center, where Bob Ryan incorporates the information into the weather forecast.
And it's been a bit breezy. One of our 4-wind schools, one of our original group, and we'll be adding some of the new ones as we go on. Northwesterly wind, 59 degrees right now at Ambeer since midnight. Nothing in the rain gauge, and there were 1 or 2 sprinkles. The chroma key is always, I think, fun for anybody who sees it because there really is nothing there but a bright green screen, or in some cases a bright blue screen. And electronically, the way it's done is wherever there is that color green, we can substitute one of the graphics or one of the satellite pictures that we've made up here. That's the reason I can't wear any bright green clothes, or I would become part of that picture. Part of the reason that we do the graphics is, in addition to the forecast, is to explain a little bit about what's going on. And now with the computers, we can take a lot of the data and then generate fairly easy graphics showing the color ranges of the temperature, blues where it's cold, reds where it's warm. So we use a lot of these computers and computer graphics as a way of drawing pictures, if you will, of the weather, and then also using them to explain what the weather will be. You know, some of the stuff that maybe was... The interesting thing about the weather is it's all around us, and we can use a lot of our senses to gather information. It's important, even in the age of computers and satellite technology, to actually look and see what's going on right now. What does it feel like? What is the wind? What are the clouds doing? How is the weather around us right now?
Curious cloud, shaped like a rat. It's transforming into a turtle. Is it a sea turtle?
I remember when I was 8, 9, 10 years old, that's when weather was my hobby. And and the sky is always changing and weather every day.